Good morning, everyone. Today is the session 20 of JEE Physics. The chapter is current electricity, and this is the question which I have taken for this session. And this question was asked in the JEE mains examination in 2013. So, in this question, we have to find the correct setup to verify the Ohm's law. ठीक है. Now ये चार figures हमको दी गई हैं and we have to find the this correct setup. Now Ohm's law की definition क्या है? That is the current which is flowing through a conductor is directly proportional to the potential difference across its ends. ठीक है. So we write that so we write this as that V is directly proportional to I, and we then write that V is equal to I R, where R is a constant which we call as the resistance of that conductor. Now this Ohm's law is true when the physical conditions are constant, like the temperature and the mechanical strain, etc. So when the physical conditions such as the temperature, mechanical strains, and etc., when they are constant, then the current flowing through a conductor is directly proportional to the potential difference across its ends. So V is directly proportional to I, or V is equal to IR, where R is a constant which we call as the resistance of that conductor. Now, in order to verify this Ohm's law, the voltmeter should be connected in parallel to the resistors, and the ammeter, it should be connected in series. So that is the setup. That is, the voltmeter, it should be connected in parallel to the resistors, and the ammeter, it should be connected in series. The voltmeter should be connected in parallel to the resistor, and the ammeter should be connected in series. So if we see these four options here we can see that in the first option, the voltmeter is connected in parallel to these resistors, and the ammeter is connected in series. In the second option, the voltmeter is connected in parallel to the resistor. However, the ammeter is not connected in parallel. This ammeter is connected in parallel, and it should be in series. So here the voltmeter is connected in parallel. However, the ammeter is also connected in parallel. In the second case, here you can see that the voltmeter is connected in series, and the ammeter is also connected in series. In the fourth case, here the ammeter is connected in series, and the voltmeter is also connected in series. So out of these four options, this option A is correct, because in this option the voltmeter is connected in parallel to the resistors, and the ammeter is also connected in series to these resistors. In these three options, it is not the case. In these three options, if I take this option number B, in this the voltmeter is connected in parallel. However, the ammeter is also connected in parallel. So this is the wrong setup. Here the voltmeter is connected in series, and ammeter is also connected in series. So this is also a wrong setup, because the voltmeter has to be connected in parallel to the resistor. Here the ammeter is connected in series, and the voltmeter is also connected in series. So this is also a wrong setup. So because the voltmeter has to be connected in parallel. So the correct option is A. That is the correct option is A, because here the voltmeter is connected in parallel to the resistors, and at the same time the ammeter is also connected in series. So this is an easy question. The only thing is that we have to understand the basic definitions of Ohm's law. That is, it states that the current flowing through a conductor is directly proportional to the potential difference across its ends. And so since V is directly proportional to I, so V is equal to IR, where R is a constant which we call as the resistance of that conductor. So in order to verify the Ohm's law, we have to connect the voltmeter in parallel to the resistors, and we have to connect the voltmeter, which should be parallel to the resistors, and the ammeter should be connected in series. So based on these two concepts, we can say that the correct option is A. So thank you very much for this session, for joining this session. In the next session, I will be continuing with the same chapter. So have a nice day. Bye.